Okay, the other question that I wanted to go over in reference to your Chapter 5 test was the free response question 1. Most of you did a really good job. There was one thing that a lot of you missed, and that would have been on Part A, where it asks for at what value or values of x does the graph of f have a relative minimum? Recall we're looking at the derivative graph here, and then one change that I made to this question or clarification, it looked like it ended and it was hard to tell exactly what was going on. So I said, hey, let's make these points actual endpoints, and in doing so we actually changed our domain to be, changed our domain to be a less than or equal to sign by including the -3 and the 5. And when we do that, it actually does change Part A. So what most of you said for Part A is you said that there's a relative minimum at the point x equals 4. So at x equals 4, and then I'm not going to write all of it out, you said there's a relative minimum, and then your answer should have been something about because f prime of 4 equals 0. It's a good idea to include that because then you're saying that it's a critical point of your first derivative. A place where a critical point of your function, where your first derivative is equal to 0 or is undefined. And then we also had to note that f prime of x changes from negative to positive at x equals 4, which means that your function changes from decreasing to increasing. You could have said that. You didn't really need to. This is good exactly the way it is. So that would have gotten you 2 of the 3 points. I made this 3 points. And the issue is that there's one other point at which f has a relative minimum. And it's based on those endpoints. So if we think about what our function is doing, derivative is positive, means that, and maybe if I even just do a quick little number line, I'm going to do it down here. And we map this out in terms of what we have going on here. So we've got from -3, and I guess I should get rid of this part because I do have an endpoint here. So let's just start at -3. So my derivative is 0 at -2, and then we get to -1, and then we have 4 and 5. Okay, it looks like our derivative is 0 at -2, -1, and 4. If we look at our signs in between there, well, our derivative is positive from -3 to -2. It starts at -3. Positive because I'm above my x-axis in here. That means my function's increasing from -2 to -1. It's negative. I'm below my x-axis here, and I'm actually still below my x-axis all the way to 4, so I'm still negative. And that was supposed to be negative signs. There we go. Which means my function is decreasing again, and then from 4 to 5, my derivative is positive. I'm back above the x-axis. Function is increasing. So most of you, like I said, had this because you got that there's a minimum right here at x equals 4, which is 100% correct, a relative minimum. But if you think about what your function's doing, it's increasing, then decreasing, keeps decreasing, and then increasing again. That means that it had to start lower over here. It went up, down, and back up. So the minimum here means because it's going down and then up. The minimum, the second minimum point, relative minimum, should have been -3. Probably not as low as at x equals 4 because I decreased a lot in here. But I did start at a point that was lower within that area. When we're talking about an endpoint, we only have to consider to one side where the function exists. So everything from to the right of -3, between -3 and -2, is going to be a positive derivative, means that my function is going to be higher than it would be at x equals -3. So my answer needed to include something of the form, there is also a relative minimum at x equals -3. because f prime of x is greater than 0 on the interval -3 to -2. So f of x is increasing for, for x is greater than 3. Something like that, or you could have said on -3 to -2, x is increasing. You're showing that it's increasing after that, meaning that it has to be a minimum at the endpoint. So you could have said at the endpoint here if you wanted to include that. And I think that would be a good enough explanation. Okay? Most of you got the rest of that question, nailed it, and did a really good job. But that was the one part, and that was a little bit of a stretch question. We had done several. If you look back at the packet where we practiced questions like this, where we were given a derivative graph, there were some where the endpoint was the only minimum or maximum in a situation. So you could look back at those for extra examples. Hopefully that helps.